video, we're going to talk about a handful of examples on how do we find the reference angle, and then we're going to do another handful of examples. Once we know how to find a reference angle, how do we then find the exact value of that angle or of that expression? So first we're going to take a look at the angle 275. So I always feel for these it's better for us to get a visual of it so we can see exactly what we're looking at here. So if we take a look at the angle 275, keep in mind that a full rotation around the circle, so here all the way around, is 360 degrees. All right, so every quarter over here is 90 degrees, right? We start at 0, we have 90, we have 180, we have 270, and then back around to 360. So the angle 275 is just going to be right past this 270. It's going to look something like this, the angle that goes all the way around and ends right here at 275. So the reference angle is going to be from the terminal side of that angle, so this line right here. All right, you want to take a look. Look left, look right, and see which side would be closer to this semicircle, our halfway point essentially here, your straight angle here. Would it be closer to go this way to reach this 360, or would it be closer to go over here to reach the 180? Well, this side over here is a smaller angle, so that's what we want to use. The reference angle is the shorter angle from the terminal side of the angle up to your straight angle here, so either the 0 or the 180. So our reference angle is going to be the angle right over here, this angle here. So if you take that 275 and what's remaining with 360, I believe that calculates, let's see, if you do 275 and you just do the calculation of here, we can do 360 minus that 275, and it's going to give us this little piece right over here. That means that this reference angle here would be 85 degrees. If we take a look at the angle negative 110 and we draw that out, keep in mind that a negative angle goes clockwise, so we're going to be starting in this direction. If we go out over here, that's negative 90. So if we go just a little bit further over here, this is what the angle negative 110 looks like. So since it's a shorter side over here, this is what our reference angle would look like. Again, it's whatever shorter from the left or to the right, right? It would go further back over here. We could get closer to getting to this 180 degrees right up there. So whatever this angle measure is our reference angle here. So if we know that a full semicircle is 180, but this bit here is 110, that means our reference angle here is going to be 70 degrees. Now, what if we're given an angle measure here in radian degrees? So same concept here. So when we're looking at a unit circle, again, we start at 0, right? Up here, your 90 degrees is going to be a pi over 2. 180 degrees is pi. And then you have 3 pi over 2 here, and then a full loop around is going to give you a full 2 pi. All right, so your semicircle here, we're either looking at a 0 or a pi. Which side is going to get us closer to that right there? So if we're looking at 5 pi over 6, 5 pi over 6, that angle is going to look like this right here. All right, so if we start at 0 and we loop around here, that's about what 5 pi over 6 is, which means our reference angle is this little angle right over here. So you can think of it this way: if one full rotation is a pi from here to here, so if we take this full pi and subtract 5 pi over 6, right? You want to do you want to do pi minus 5 pi over 6 is how you want to think of it. You can work that calculation, but just this tiny little piece here would be a pi over 6 for that little bit there. For negative 15 pi over 6, so same concept here, except we do have a negative angle for this one here. Now if we take a look at our last example, we are given negative 15 pi over 4. Negative 15 pi over 4 is almost 2 rotations around our unit circle. So in order to calculate this one, we need to actually simplify our radian measure first. So we want to go ahead and find the coterminal angle of that. If you need help in finding coterminal angles, go search that video up and maybe watch an example of that really quick. But since we have a negative angle, in order to find the coterminal angle of that, we want to add 2 pi to our current measure. So we want to take negative 15 pi over 4. We want to add 2 pi to it. And when we do that, we are left with 7 pi over 4. That would be the coterminal angle, I'm sorry, a negative 7 pi over 4 would be the coterminal angle of our given angle, negative 15 pi over 4. So negative 7 pi over 4 is the angle that we actually want to look at for this example. Since it is negative, we will be moving clockwise direction, and a 7 pi over 4 is going to be an angle about right over here is where it would fall. So this angle here is our 7 pi over 4. Our reference angle then is just going to be this amount right over here from the terminal side of this angle on up to 180, or since we're in radian here, up until pi. All right, so really if we just take that pi and we subtract the 7 pi over 4 that we have here, it will give us this amount here. So if we take 7 pi over 4, again, subtract that from pi, it will leave us with a measure of pi over 4 for our reference angle right over here. In order to figure out sine of 315, what we're going to want to do first is we're going to want to find the reference angle for 315. If we draw out 315, so 315 is going to give us this angle right over here. So a full apparatus 360, we're only going to 315. So our reference angle is this little bit here. So if we take 360 and we subtract the 315, that's going to give us this angle here. Our reference angle of sine 315 is sine 45. So 45 degrees is what this little mini section right here would be. So we want to find the exact angle for sine 45. There's a couple ways that you can do it. If you have a scientific calculator, you can simply just type in sine of 45 into your scientific calculator and get the answer that way. A lot of times when it comes to this point here in a trig course, a lot of times instructors do not allow scientific calculators for these problems, simply because you can just type it in, you can get a solution. In that case, you want to take a look at sine 45 and you want to pull up your unit circle, okay? I don't have a unit circle here available on us. When you pull up your unit circle, you are looking at sine 45 and you want to take a look at the coordinate for that. The coordinate for sine 45 should be a square root of 2 over 2, comma square root of 2 over 2. Keep in mind that when you're taking sine of a given value here, sine is the y coordinate for that coordinate here. So if you take a look at sine 45 on your unit circle, you should have the point square root of 2 over 2, comma square root of 2 over 2. Sine of that is just the y coordinate for it. So sine 45 is square root of 2 over 2. Just pull the y value from this coordinate here. If we take a look at cosine 4 pi over 3, the first thing we want to do is find the reference angle for that. So if we draw 4 pi over 3, so that angle looks about right here. The reference angle for this here is going to be this little section here. Again, keep in mind the reference angle is the terminal point all the way close to your straight angle. So for us, it's going to be going back over here to pi. So in order to figure out that reference angle, we would take the cosine 4 pi over 3, we would subtract pi from it. Our reference angle that we're actually looking at here would be cosine pi over 3. That's just what this tiny little amount over here would be. So they want us to calculate cosine of pi over 3. Now, keep in mind when you go to your unit circle and you pull up cosine pi over 3, that value is 1/2. And then square root of 3 over 2 is the point for cosine pi over 3. Keep in mind that cosine t is equal to your x value. So if we want to find the cosine of pi over 3, again, we find the point, which is this here. We want just the x value of it. So cosine pi over 3 is 1/2. Last example here in order to find the exact value of cosine 1035, or to find the exact value of the reference angle of cosine 1035, there's a couple things that we need to do. First off, the angle cosine 1035 is too large. You want to find the coterminal angle for that, which means since this is a large angle, and this is in degree measure, you want to subtract 360 and continue to subtract 360 from 1035 until you get a measure within 0 and 360. So if we take 1035 and we subtract 360 from it, you get 675, which is still too large. If you subtract another 360, you are left with cosine 315. That would be the coterminal angle of cosine 135. So in order to get the reference angle, which is what our problem is asking for, so we want to go ahead and draw a cosine of 315, which is almost a full loop around our unit circle. Right? Again, a full loop is 360. We only want to go to 315. So the reference angle for 315 is going to be this little section right over here left over. So if we take the full loop at 360 and we subtract the 315, we are left with 45 degrees. So the reference angle of cosine 315 would be cosine 45.